Welcome to SDN Tech Networking Podcast, world's first human-curated AI podcast.
Imagine a highly classified blueprint for a new nuclear submarine.
Okay.
If you had to guess how that blueprint might get stolen, you'd probably picture, I don't know, some elite spy hacking into a heavily fortified Pentagon server.
Yeah, like some crazy movie sequence with lasers and, code scrolling down a screen.
Exactly. But what if that blueprint was actually stolen through an internet-connected pressure valve, just like sitting on a factory floor in Ohio?
Wow. Yeah. I mean, it sounds like a Hollywood plot, but that is actually the exact reality of modern cyber warfare right now.
That's wild.
It is, because the Department of Defense, they don't build submarines in a vacuum. They rely on this massive defense supply chain spread across thousands of private companies.
Right.
So you have these massive aerospace contractors, sure, but you also have these tiny specialized machine shops that are just making like single components.
But the front lines of national security aren't just military bases anymore. I mean, they're literally civilian factory floors.
Yeah, absolutely. And that creates a massive, frankly, a terrifying blind spot, because a physical fortress doesn't really matter if the digital backdoor at some tier 4 subcontractor is just left wide open.
And adversarial nation states, they know this, right?
Oh, they definitely know this. They don't attack the fortress directly anymore. They go straight after the weakest link in the supply chain.
Which brings us to our focus today. Welcome to the deep dive, everyone.
Thrilled to be here.
Today we are unpacking how the DoD is attempting to close that exact back door with this sweeping cybersecurity framework called CMMC 2.0.
Right, the Cybersecurity Maturity Model Certification.
Exactly. And based on our source material for today, which is a really detailed vendor-neutral mapping guide on how to achieve this compliance, we're going to explore how this is just completely reshaping the defense industrial base.
It really is a massive shift.
But more importantly, for you listening, we're going to look at why this is a masterclass and how all critical infrastructure needs to be protected moving forward.
Yeah, because the stakes here go way beyond just, simple data loss. We are going to be talking heavily about industrial IoT today, the Internet of Things on the factory floor.
Because a compromised valve is worse than a stolen PDF.
Exactly. When you compromise industrial equipment, you aren't just stealing files. You are actively threatening physical safety and, operational continuity.
So if the government is suddenly demanding this massive overhaul of how all these private companies handle security, what exactly was broken with the old system?
Well, the old system was essentially an honor system.
Really? An honor system for defense contracts?
Basically, yeah. It operated on this trust but verify mentality. So the government would award a contract and the company would sign a document claiming, they had adequate security in place.
Okay.
But the detailed verification, the actual auditing, often happened way after the fact, if it even happened at all.
That seems incredibly risky given what we're talking about here.
It was. It led to major supply chain vulnerabilities, huge unexpected costs to clean up breaches, and just excessive failed audits when the DoD actually did look under the hood.
Right.
So with CMMC 2.0, the DoD flipped the script entirely. The new mandate is certify before you bid.
Certify before you bid. That's a huge change.
Huge. I mean, you cannot even play the game or be a sub-supplier on a bid if you haven't proven that you meet the security standards up front.
Okay, so let's unpack this for a second. What exactly are these companies proving they can protect? Because we aren't talking about like top secret nuclear launch codes here.
No. Classified information has its own entirely separate, much stricter set of rules.
Okay, good to know.
Yeah, CMMC is specifically designed to protect sensitive but unclassified information, and the government breaks this down into two main categories, FCI and CUI.
Let's define this for the listener. What is FCI?
So FCI is federal contract information. This is kind of the basic foundational stuff. It's information provided by or generated for the government under a contract that just isn't intended for public release.
Okay, so like internal communications, basic project timelines, maybe vendor lists.
Exactly. It's sensitive, sure, but it's not critical.
And the second one?
The CUI.
CUI is Controlled Unclassified Information. Now, this is the heavy hitter.
The important stuff.
Right. CUI is information the government creates or possesses that actually requires safeguarding according to specific laws or regulations.
So give me an example of CUI in the real world.
This could be detailed technical drawings of a weapon system component, or proprietary manufacturing processes, or sensitive technical schematics.
Stuff you really don't want a foreign government getting their hands on.
Exactly. If CUI falls into the wrong hands, it directly impacts national security.
So how do they measure a company's ability to protect all that? Like, do they treat a 50-person machine shop the exact same way they treat some multi-billion-dollar aerospace giant?
They don't, which is, frankly, why CMMC uses a tiered approach. There are 3 distinct maturity levels. Okay, walk us through them.
So level 1 is foundational. If your company only handles that basic FCI we talked about, you just need to implement 15 basic cybersecurity hygiene practices.
15 practices? Like what?
Just simple things, like requiring passwords and installing basic antivirus software. And for level 1, you can actually still do an annual self-assessment.
I mean, that sounds like table stakes just to operate a business in the modern world anyway.
It really is. But then you jump to level 2, which is advanced. And this is where it gets serious, because this is the level required if you handle any of that sensitive CUI.
The heavy iterative.
Right. Level 2 demands compliance with 110 specific security practices.
110, that's a big jump from 15.
It is. And these are mapped to a government standard known as NIST Special Publication 800-171.
Okay, instead of getting bogged down in the NIST acronyms, what do those 110 practices actually look like in reality for a company?
It's a completely comprehensive overhaul. It covers everything from like strict access controls, knowing exactly who's on your network at all times, to robust incident response plans.
Like having a plan for when you actually get hacked.
Right. Plus, mandatory employee training and complex encryption protocols. And crucially, this is the big one for level 2, you can no longer self-assess.
No more honor system.
Exactly. You have to bring in an authorized third-party auditor, which they call a specialized assessment organization, every 3 years to meticulously verify you are actually doing all 110 things.
Wow. And I assume level 3 takes that even further.
Oh, yeah. Level 3 is the expert tier. It adds 24 extra highly stringent requirements specifically to protect against sophisticated, advanced, persistent threats.
Like state-sponsored hacking groups.
Exactly. This is for the absolute most critical CUI. And for level 3, the Department of Defense themselves actually conducts the assessment.
So I was reading through the source material on how auditors approach that middle tier, level 2. And there's this concept that really jumped out at me regarding the CUI.
The contagion concept.
Yes. The framework essentially treats this controlled unclassified information as an active contagion.
The contagion model is really the absolute best way to understand an auditor's mindset.
How so?
Well, the core rule of CMMC is that any asset that stores, processes, or transmits CUI is in scope for the assessment. But it goes further than that.
Right, because of the network.
Exactly. Any asset that provides security for those systems or is on the same unsegmented network as those systems is also completely in scope.
It's like bringing a kid with the flu to a daycare center.
Yes, perfect analogy.
If you don't define a strict boundary or a quarantine zone immediately, you just have to assume the entire daycare center is infected.
Right.
Like every toy, every surface, every other kid.
Yeah.
If a contractor can't prove exactly where the CUI isn't, the auditor just has to assume it is everywhere.
Which means network architecture and boundary definition become the absolute first step for any contractor.
You have to build the quarantine zone.
Yes. If you don't have a clear, logically validated firewall separating, say, the engineering team's computers from the rest of the company, that contagion principle just takes over.
So suddenly, the Wi-Fi in the corporate cafeteria or like the HR department's payroll server is subjected to a massive Department of Defense audit just because they share a network with the engineers designing the submarine parts.
Yes, 100%. Without proven boundaries, your entire corporate environment falls into scope.
It sounds expensive.
It's incredibly expensive. Trying to secure a massive, unsegmented network to meet those 110 rigorous level 2 standards is logistically overwhelming and, honestly, financially crushing for almost any business.
Okay, so if the CUI contagion means any connected device is suddenly in scope without proper boundaries,
Yeah.
what happens when we look at the actual factory floor?
The the operational side.
Right, because a robotic assembly arm isn't a laptop.
Yeah.
You can't just install normal IT software on a giant manufacturing robot.
And this is what the industry calls the operational technology, or OT dilemma.
The OT dilemma.
Yeah.
Let's dig into that.
So CMMC explicitly requires contractors to safeguard all assets in their relevant environment. And the framework specifically calls out specialized assets.
Like what kind of assets?
Industrial IoT devices, government-furnished test equipment, programmable logic controllers, and just automated manufacturing systems in general.
Why do these specialized assets create such a huge problem for security teams, though? Like, why can't the IT guy just run a normal antivirus scan or a vulnerability check on the factory equipment?
Because traditional IT security tools were never designed for operational technology. It's a totally different world.
How different?
These industrial devices operate on proprietary, often decades-old legacy protocols. I mean, they speak a completely different digital language than a standard Windows machine.
Okay.
But more importantly, the physical hardware itself is fundamentally different.
Give me an example of that.
Take a legacy programmable logic controller, a PLC that controls, say, a massive chemical mixing vat.
Okay, a big chemical vat.
That PLC has a tiny, fragile memory buffer. It was built for one thing only: continuous, reliable operation.
Right. Don't stop mixing the chemicals.
Exactly. It was not built to handle network traffic spikes. In the IT world, if you run a vulnerability scan, it pings a server thousands of times a second.
And the server doesn't care.
Right, the server easily handles it. But if you run that same active scan against an industrial PLC, you will flood its tiny memory buffer immediately.
So it crashes.
It crashes hard. And when a PLC crashes, the physical machinery it controls halts. Or worse, acts entirely unpredictably.
Oh, wow.
Yeah, you could accidentally shut down a manufacturing line, disrupt a municipal power grid, or cause a pressure valve to burst.
That is terrifying.
It is. Assessing risk in an industrial environment is entirely consequence-based. You aren't just worried about a database getting stolen anymore. You have to account for physical safety and severe environmental harm.
Wait, I have to push back here for a second.
So go ahead.
You're saying a 50-person manufacturing company needs to secure 15-year-old robotic arms without ever scanning or patching them, and if they fail, they lose their government contracts.
That is exactly what I'm saying.
How is that not going to instantly bankrupt the lower tiers of the defense supply chain? Like, how is this even possible to implement?
Well, look, it's a massive financial and technical strain. There is absolutely no denying that. The DoD is aware of the burden,
But they're pushing forward anyway.
because they've made the calculation that the cost of widespread supply chain compromise by adversarial nation states is just far worse than the cost of compliance.
Fair enough. But technically, how is it possible?
It forces a complete pivot in how security is applied. You have to abandon active scanning completely on the factory floor. The framework requires a shift to passive discovery and continuous monitoring.
Okay, let's look at the mechanism of that. How do you find vulnerabilities if you literally can't actively look for them?
You use deep packet inspection to listen to the network traffic passively.
Listen to the traffic.
Right. You parse those proprietary industrial protocols as they flow across the network switches, but without ever interacting directly with the fragile endpoint devices themselves.
So you aren't poking the PLC.
Never poke the PLC. You learn what's there and what it's doing purely by observing the data in transit.
It's like wiretapping a foreign embassy.
Okay, I like that.
Like, at first you don't understand the language and you don't know who is inside, but you just listen.
Right.
And over a month, your system learns that every day at 3 p.m., the ambassador makes a 5-minute encrypted call to a specific location. You don't need to actually break into the room to know what's normal.
That is exactly how it works. And the sources detail that artificial intelligence and machine learning are basically required to establish these baselines.
Because it's too much data for a person.
Exactly. A human analyst can't monitor thousands of microtransactions per second across an entire industrial floor.
Right.
The AI learns the baseline. It notes that, hey, a specific temperature sensor only ever talks to one specific controller. It operates on a known hardware type, and it only sends a specific command protocol.
So it builds this incredibly detailed behavioral profile for every single specialized asset on the factory floor.
Right. And once that baseline is established, any deviation triggers an immediate alert.
Like if it acts weird.
Exactly. If that temperature sensor suddenly tries to establish an external connection to an unknown IP address, The AI sounds the alarm.
And you detect the anomaly without ever having to touch or scan the fragile industrial device itself? That's brilliant.
Really is. It's the only way to do it safely.
Now, the mapping guide also emphasizes that this passive monitoring has to cover the wireless spectrum too, not just the hardwired network cables.
They have to cast a very wide net here. The framework requires monitoring the entire wireless spectrum from 800 megahertz all the way up to nearly 6,000 megahertz.
Okay, when you say wireless, are we just talking about someone's rogue Wi-Fi router in the break room?
Oh, it's way broader than that. That spectrum range covers Wi-Fi, sure, but it also covers unauthorized Bluetooth connections, cellular signals, LoRaWAN IoT networks, and even drone frequencies.
Drone frequencies? Wait, really?
Absolutely. Think about it. You can have the most expensive firewalls in the world on your wired network. But if a commercial drone flying near the facility can connect to an unpatched Bluetooth sensor on your roof, your boundary is totally compromised.
Wow. And the auditor wants definitive proof that this isn't happening.
They want time-stamped, context-rich evidence that these boundaries are intact across all spectrums. You have to prove an asset is either entirely isolated, meaning absolutely zero logical access to the CUI environment, or that it uses controlled access through a highly monitored gateway.
Here's where it gets really interesting to me. The sources highlight a specific requirement for Level 2 and Level 3 that feels a bit like, I don't know, Inception.
I know exactly what you're going to say.
Contractors have to demonstrate how they protect their security protection data, or SPD.
It's a vital requirement, especially when dealing with critical infrastructure.
It's like hiding the blueprints of a bank vault's alarm system so the robbers can't study your blind spots.
Yeah.
Like, you literally have to secure the data about your security tools. Why is this so heavily emphasized in the CMMC framework?
Because advanced threat actors don't just kick down the front door with a noisy malware attack anymore.
Right, they're sneakier than that.
Very sneaky. They do quiet, methodical reconnaissance. If they can access your security protection data, they can see exactly what your AI baseline considers normal.
Oh, man. So they can review your firewall rules and identify the exact blind spots in your passive monitoring.
Yes.
How do they actually weaponize that knowledge, though?
They use a technique called living off the land.
Living off the land. What does that mean?
Instead of dropping custom malware that an antivirus program might catch, a hacker who knows your baselines will literally use your own approved administrative tools against you.
So they use your own system to hack you.
Exactly. They will hijack legitimate credentials and use standard system tools like PowerShell to move laterally through the network.
So to the monitoring system, the hacker's actions look exactly like a normal network administrator just doing their everyday job.
Precisely. They blend right in with standard, approved industrial traffic. If they know the alarm system's blueprints, they know exactly which floorboards don't have pressure sensors.
That makes perfect sense.
In a consequence-based environment where a breach means a factory explosion or a compromised submarine blueprint, you simply cannot afford to let the enemy see the map of your defenses.
So what does this all mean in terms of a timeline? Because this level of AI-driven passive monitoring, strict wireless spectrum control, and boundary validation, I mean, this isn't something a company can implement over a weekend.
No, it takes months, sometimes even years of preparation, and the timeline is incredibly strict.
Walk us through it.
So CMMC 2.0 superseded the old version back in December of 2024, and as of October 1st, 2025, the DoD required the new certification clauses to be included in relevant contracts.
Right, they structured the rollout in 4 phases, didn't they?
Yes. Phase 1 kicked off in 2025, which primarily required those Level 1 or Level 2 self-assessments just to get the ball rolling. But we have to look at where we are right now. Today is July 2026. We are sitting squarely in the middle of Phase 2.
Phase 2 is the big escalation, right?
It is the absolute turning point. Phase 2 means bringing in a C3PAO.
Which is?
A certified third-party assessor organization, basically an independent, heavily vetted auditing firm. They are now required for contractors handling CUI.
So right now, today, it's real.
It's very real. You can no longer just sign a paper saying your security is good. An external auditor is physically or digitally showing up to verify those 110 requirements, and they are demanding the logs and the evidence.
Okay, let's bring this back to our real-world scenario. You are the security lead at that mid-sized manufacturing plant in Ohio making the submarine valves.
Okay, I'm the security lead.
You've got a factory floor full of legacy IoT equipment that's been running reliably for 15 years. Because we are in Phase 2 right now today, What happens if you assume those old industrial sensors were out of scope, but the auditor shows up and finds there isn't a proven digital boundary?
It triggers an immediate compliance failure.
Just like that.
Just like that. Because of the COI contagion principle, if you haven't defined and proven the boundary, that legacy equipment is instantly in scope of the audit.
Right.
And because it can't be actively patched or scanned to meet those level 2 standards, you fail.
And failing the audit means you lose the ability to bid on the DoD contract.
Which, for a specialized manufacturer, likely means losing their entire business model overnight.
That is brutal.
It is, but this scenario really highlights the absolute urgent need for automated asset inventory. You have to know exactly what is on your network right now.
You can't protect what you can't see.
Exactly. You need that passive discovery to find every device, every connection, and every rogue wireless signal before the auditor does.
Because if you don't know a device is there, you obviously can't prove it's isolated from the CUI.
Exactly. Once you have the inventory, you have to rapidly implement logical isolation to wall off that legacy equipment. You have to prove, with historical data logs, that the old valve sensor has zero capability of communicating with the server holding the submarine blueprints.
And time is running out to get this done.
Very quickly. Phase 3 hits next year in 2027, which introduces the DoD-led Level 3 assessments for the most sensitive contracts.
Wow.
And by Phase 4 in 2028, full Level 1 through Level 3 compliance is completely mandatory across all relevant defense contracts.
So the window for preparation is closing fast.
Very fast.
Well, we are clearly witnessing a massive paradigm shift here. The government has entirely abandoned the culture of trust, but verify in favor of a rigid, uncompromising certify before you bid reality.
Absolutely.
And what we've learned today is that protecting the defense industrial base isn't just about, locking down laptops anymore. Securing specialized industrial IoT assets on the factory floor is arguably the most complex piece of this entire puzzle.
For sure.
It requires completely abandoning traditional IT scanning and embracing a consequence-based mindset using non-disruptive AI-driven monitoring.
It is a massive technological undertaking, there's no doubt about it, but it's an absolutely necessary one. The digital backdoor into the defense supply chain simply has to be closed.
Which leaves us with a pretty compelling, broader question to ponder for the listener.
Oh.
Yeah. If the Department of Defense is enforcing this incredibly strict framework, they are this worried about the physical safety and the environmental impact of compromised industrial IoT on a factory floor, should civilian industries be paying attention?
It's the critical question of the decade for security professionals right now.
Think about municipal water facilities, regional healthcare networks, civilian power grids, or even just the developers building massive smart home ecosystems.
Right.
Should they really be waiting for a government mandate? Or should they be proactively adopting this exact same infectious boundary and passive monitoring mindset right now before a major cyber catastrophe forces their hand?
That's a great point. The threats don't differentiate between a defense contractor and a civilian power plant. If the DoD doesn't trust a digital wall without constant verification, civilian infrastructure shouldn't either.
So true. So the next time you picture a secure government facility, forget the thick concrete walls and the armed guards. The real fortress is invisible, it's behavioral, and it's constantly listening to make sure the contagion doesn't spread. Thanks for joining us on this deep dive, and we'll catch you next time.